guys, today we are going to apply everything that we've learned to do some trig applications. So our objective is just to use our knowledge of right triangle trigonometry to solve application problems. So we're not really learning anything new, we're just going to be setting up some problems. Trig is actually used in a lot of real world applications, and I have a few here. This is definitely not all of them, there are plenty, but I just wanted to bring up a few examples. So triangulation is a surveying method that measures angles in a triangle formed by 3 survey control points. Using trigonometry and the measured length of one side, the other distances in the triangle can be calculated. So it's used a lot in surveying, in architecture, engineering, and construction. My dad was a construction manager at the University of Utah for many, many years, and he said that he used trigonometry all the time. Much of architecture and engineering relies on triangular supports, finding the lengths of cables, the heights of support towers, and the angle between the two when gauging weight loads and bridge strength. It also allows builders to correctly lay out a curved wall, figure the proper slope of a roof, or the correct height and rise of a stairway. So there's many applications in architecture, engineering, and construction. You can use it to measure the height of a building or mountain without, actually having to measure it. As long as you know that your distance from the mountain or the building, and then you measure the angle of elevation from yourself, looking up at it. And we were actually going to do a project like this before the soft closure where we would go outside and measure some of these things. But unfortunately, because of the soft closure, we aren't able to do that. But there's a simple tool that you can build that helps you to measure that angle of elevation. And then you can estimate very closely the height of buildings or mountains, or trees or whatever. And so yeah, there's some of the applications. There's many more, but those are a few. So these questions are going to be a little silly, but they will give you an idea of how these can be used. Okay, so let's go ahead and get started. So a damsel is in distress and is being held captive in a tower. So let's draw a tower. She's here in this tower. Her knight in shining armor is below with a ladder. So here's her knight in shining armor here. The ladder is going to be leaning up against the tower, and this distance will be how far away the knight is from the tower, and this will be at her 90-degree angle. When the knight stands 15 feet from the base of the tower and looks up at his precious damsel, the angle of elevation to her window. So an angle of elevation is always from where you are, you're looking upward. So if you're talking about an angle of elevation from where the person is standing, that's going to be this angle here. And so this is going to be 60 degrees in our example. And how long does this ladder need to be in order to rescue her? So now we've set ourselves up a triangle. Now we just need to use what we've learned in the past few days to solve for x. So the 15 feet would be the adjacent side to 60. And this is the hypotenuse. So since it uses adjacent and hypotenuse, I know it's going to use cosine. So cosine of 60 is equal to 15 over x. And remember, when we have x on the bottom, we need to get it off by multiplying both sides by x and then dividing both sides by cosine 60. So in my calculator, I'm putting 15 divided by cosine 60. One thing that I will say here is that on every example on your homework, I do want to see a triangle drawn. Please draw the triangle each time. Okay, so this would be 30 feet. So our hypotenuse, our ladder here would have to be 30 feet for him to rescue this damsel in distress. Okay. But yeah, for every question, make sure you draw a triangle and label it. Suppose you're flying a kite and it gets caught in the top of a tree. So here's my tree. Here's the kite. It's stuck up here. You'll let out, let's see, you've let out 100 feet of string from the kite. So if you're down here holding onto your string, the string of your kite, you've let out 100 feet. So that would be our hypotenuse. And the angle that the string makes with the ground, so here's the string, here's the ground, that would be this angle, is 75 degrees. Obviously my thing is not to scale. Instead of worrying about how to get your kite back, you wonder, how tall is that tree? So you're wondering the height of this tree. So here's our right triangle. 75, that makes this the opposite side, and this is the hypotenuse, so we're going to use sine to set this up. So sine of 75 will equal the opposite side, which is x, over our hypotenuse, which is 100. On this one, we just simply need to multiply both sides by 100 to get x. So 100 times sine 75. Do remember that you need your calculator in degree mode for these. So that would be 96.59. So I'm going to round it off to 96.6 feet. It's a tall tree. All right. Again, remember as you're going through the video, sometimes it's a good idea to pause it and try the question on your own first and then come back. A submarine traveling at a depth of 250 feet. So here's the water. The submarine is coming along here and is 250 feet down from the surface of the water. Let's see. It dives at an angle of 15 degrees with respect to a line parallel to the water surface. So this line right here where it was traveling 250 feet down, it now is going to dive down from that line parallel to the surface of the water 15 degrees. And it travels a horizontal distance of 1,500 feet. So that means this distance from here, where it started to dive, to here is 1,500 feet. What is the depth of the submarine after the dive? So we need to find x here, which would be this depth here, but then we'll also need to add this 250 feet because it was already 250 feet down when it started diving. So here's my angle. Here is 15 degrees. This would be the opposite side, and this is the adjacent side. So we're going to use tangent of 15 degrees equals x over 1,500. So in order to solve this, I need to multiply both sides by 1,500. So in my calculator, I've got tangent 15 times 1,500. Make sure you close your parentheses if you put the tangent in first. So x equals 401.9 feet. So that's this distance, but then we also need to add the 250 feet that he had already dived, or that he was already traveling when this whole dive started. So we have 651.9 feet. Okay. So again, the main thing here is make sure you draw a triangle so that you can really decide which side is which and all of that stuff. Kelly is walking to her office building, which she knows is 150 feet high. So here's her office building. Its height is 150 feet. The angle from the top of the building, so here's the top of the building, to her current location. So here she is walking towards the building. So this angle that goes from the top of the building down to where she is 6 degrees. How much further does she need to walk to get there? So we're looking for this side right here. This is our right angle. So this would be the opposite side from our 6-degree angle. This is our adjacent side. So again, we're going to use tangent. So tangent of 66 degrees equals the opposite side, which is x, over the adjacent side, which is 150. So just multiply both sides by 150. So x equals 150 times tan 6. So I'll hurry and put that in my calculator. And that is equal to 15.8. I'm rounding again. And it was in feet, right? Yeah, so 15.8 feet is how much further she needs to go. Okay, so go ahead and give some of those application problems a try. If you need any help or have any questions, please don't hesitate to ask. Just hop on Zoom or email me, and have a great day.